Let me try once. Oh, oh, Maria. Oh, Maria.
నడుస్తుంది కదా ముందు I think let's start off. So last class we saw all about Matplotlib, right? So today we'll see how to do the same thing with Seaborn. Okay, so like I mentioned yesterday, right? So Seaborn has made it kind of easy for you to follow things. Sorry, rather remember things. Right? So you just need to remember the cat plot and rel plot, and you can just mention what kind you want, right? So all functions are kind of uniformly written, right? So you don't have to remember multiple functions here. So now coming to Seaborn. So Seaborn gives you more flexibility, right? So in creating graphs and all. So you can choose color palettes, right? So color palettes are kind of, it's like setting a theme, right? So if I've given you a link to the tutorial here, right? So which is from the documentation of Seaborn. So you can see, you can set different color themes. So there are so many palettes to choose from, right? So this is called tab 10. So you have pastel shades, muted shades, bright shades, right? So deep, colorblind, dark, right? So all those shades, palettes are there. So these palettes are given some names, right? So for example, this is called set 2, right? So where you have kind of pastel shades. I think there is something called pastel also. Then this is called paired palette. You can see light and dark combinations, right? So you can just refer to the documentation to see what all palettes are there, right? So there is something called Rocket, Marco. So these are all very commonly used palettes, right? Flare, Crust, Magma, right? So Viridis. These are all very commonly used names, right? But you can always refer to the documentation to see what all palettes are there. So if you want to see what is the current palette, right? So what happens is when you set a palette for your in your file, whatever graphs you draw, it'll select the colors from those palette, right? From that palette only. So if you want to see what is the current palette, right? I have to import, let me import Matplotlib. And we also need to import Seaborn, right? So Seaborn is imported as SNS, right? So import Seaborn as SNS. So this is the commonly used abbreviation for Seaborn, right? So just like for pandas, it is PD. Here it is SNS, right? So you can say SNS dot color palette. So this will show you what is the palette currently set, right? So now whatever graphs you draw, it will take colors from this. For example, if you're doing a pie chart, it will take colors from this palette, right? So you can change the palette if you're not happy with these colors, you can always change the palette. But before that, you want to see what colors are there in a particular palette, right? So let us say set 2. So I can say SNS dot color palette set 2. This will show you what colors are there in set 2. Right, so you can see this is kind of a pastel version of this, right? So I think there is something called pastel also. So can you see whatever current palette is there? This pastel palette is a more pastel versions of those colors, right? So like that, if you want to see what is the colors, what are the colors in Viridis, for example. Viridis. right? So it will show you these are the colors that are available. So if you mention the name of the palette, it will tell you what all colors are there in it, right? So let us set our palette to pastel, right? So we don't want these bright colors. So we'll say SNS dot set color palette or set palette pastel, right? Now, if you see what is SNS dot color palette, so this will show you the current palette, right? So the current palette is now the pastel version and not this version, right? So setting a color palette allows you to choose the theme for your graphs. So anything that you draw hereafter will take values from this. But apart from this, it is also possible to specify, to specify for each graph, what is the palette you need to be using. This is the overall, right? You can override it. For an individual graph, you can say, see, for this graph, use a different palette, right? So that is possible. So this is about color palettes, right? So in SNS, Seaborn. So now coming to what did I want to say? I wanted to say something before. Yeah. So just like you have these color palettes, right? So built-in color palettes, Seaborn package also comes with a set of data, right? So there are some data sets available. So that means you don't have to read from CSV files, right? So you can do that also, but you can also directly load it from the data, from the Seaborn package, right? So if you want to see what all packages are there, you can say SNS dot get dataset names. So these are all the different data sets available, right? So you're probably familiar with IRIS. Titanic data set is there. So what we'll do, we will use the TIPS data set a lot here, right? And IRIS also we can use if required. Anything else, maybe we will load it from the CSV file, right? So how do you load this particular data? You will just say load a data set, right? So let us say I will load the TIPS data set into a variable called TIPS. So I can just say SNS dot load data set and within brackets say TIPS. So this data gets loaded into this variable called TIPS, right? So let us see TIPS dot head. So can you see the TIPS data set has been loaded into our TIPS variable, and that will be a data frame, right? So this returns a data frame. So we'll be using this data set a lot, right? So here, what are we talking about? We are looking at how much tip people are giving, right? So when you're going out for food, what is the tip being paid, right? So later on, we want to use this to predict how much tip will a person get under certain conditions, right? So what all are we looking at? See, what is the total bill, right? So your tip probably depends on total bill, right? So usually people, what they do, they pay a percentage of the total bill as tip, right? So we are looking at total bill, then we are looking at the gender, right? So maybe female tend to pay less, males tend to pay more, or it could be the other way around, right? So either way, this could be a parameter, whether they are smokers or not, on which day they came, right? So what is so when you say day, there are 4 options here. Thursday, Friday, Saturday, and Sunday. Right? So, and time can be dinner or lunch. So only 2 values possible here, only 4 values possible here. And size, right? So size is numerical. Right? So how many people were there in the party? So if you take the first record, right? So how do we interpret this? 2 people went out to have dinner on Sunday, right? So they were non-smokers. So it was a female who paid the bill. The total bill was 16.9, and the tip they paid was 1.01, right? So this is how you need to interpret it. Remember the column names, right? So we'll be doing a plot based on that. Okay, so this is about your tips data set, right? Now we will use this to create our charts and all. So let's start with this, right? So categorical plot. So categorical data versus numeric data, right? So there is something called strip, swarm, box, violin, point, bar plot. So let's try, right? So let's try bar plot first. So we had created this one, right? This also we created a data frame, if I remember right. Where did we do this? Okay, we called it bar data, right? So we should have called it student data. But anyway, right? So we'll take this. Plot a bar chart. So what should we do? I can just say SNS dot cat plot and category is equal to bar, right? So let's keep it simple. So we'll say SNS dot bar chart. Sorry, SNS dot cat plot. Data comes from bar underscore data, right? So your X value will be, let's see what is, okay, we didn't load that bar chart data, no? So I think let's see what is there in bar data. Did I run it again? Right. Bar data dot head. Run it again.
It's a tip now.
Sorry.
I said data name is tip now over there.
Yeah, but I didn't run it, I think. Yeah. So this is our bar data. This is tips. I want to use bar chart. Okay, that's a different data. All right. So here I'll say X is equal to students. I have to say Y is equal to courses, and kind is equal to bar. And so this is the bare minimum that we need. So PIT dot show. Right, so this is the bare minimum that you need. So any plot that you want, right? So you'll specify what is the data. From this, what is the which column you are going to use as X, which column you are going to use as Y, and what kind you want, right? So let it be. So this is the basic thing that you need, right? So, okay, try this. If you have created that data frame yesterday, you can try that. Otherwise, don't bother, leave it. I think it's better the other way around. We'll make y is equal to students and x is equal to courses. So one thing is your Matplotlib and Seaborn works hand in hand, right? So like I mentioned, Seaborn was built around Matplotlib. So so you can create a chart using Seaborn and you can ask Matplotlib to print it, right? So here we are saying plt.show. So we are asking Matplotlib to show the graph, but the graph itself has been created using Seaborn, right? So similarly, the title left, X value, Y value, all those you can use from PLT only, right? So you can use the methods interchangeably. So you can use them together. So here, the only problem in Seaborn is setting the figure size, right? So it's not uniform for all of those. In some cases, you have to specify the aspect. In some cases, you have to specify it differently. But here, let's say height is equal to, let's say 4. And aspect is equal to, let's say 2, right? So let's see. So what happens here is, to specify the size of the figure, you have height, right? So that is this one. And the width is calculated by taking aspect into height. So this is basically 4,8, sorry, 4,8, right? So this is like setting your figure size as 4,8. So, but you have to mention it like this: height has to be specified and the aspect has to be mentioned. Width will be 2 times height, sorry, aspect times height. So this is a 4/8, sorry, 8/4. Okay, so I can change it. I can make it 3, 1. Let's see what happens if it is 3, 1. It'll heighten, it'll become a square thing, right? So instead, let me try 1.5 times 1.5. So this is also fine, right? So you can use PLT to give it a title. So you can use the PLT methods also, right? And the Seaborn methods also. So this is a simple bar plot, right? So Seaborn doesn't have anything called a horizontal plot. In Matplot, we had something called bar edge, right? So that is not available here. But you can still get a horizontal plot. All you need to do is you need to interchange X and Y, right? So that's all. That's what I had got earlier, right? So you just need to interchange X and Y and you will get a horizontal plot, right? So take the same thing. And just say this is X and this is Y. So you'll end up getting a horizontal chart, right?
Hello.
Yeah.
Yes, ma'am, if we use plt.show, so as we can see here, like the output will come at bottom, okay, of the code. But in somewhere like in a PyCharm is open in a different window. So what we call on that window?
What we,
That window or
yeah, in PyCharm, it will open in a different window.
so what we called it to that window?
What we call it?
Yes. In which window it's open? Like I just want to know, like we are able here to see that like we are called as like a result window or something. So what is the
I
name for
don't know
that
what
window?
it is called, actually. That's what I'm thinking.
I'm sorry.
I don't know what that is called. That window name, I don't know what it is called.
Okay.
But here it will print it here itself, right? So Jupyter will render it here itself.
Okay.
So
No, actually I'm trying in a PyCharm, so it's
yeah, I don't use it much. I don't know what it is called. Um, so is it coming as a separate floating window?
Yes.
Okay. I don't know the name of that. There is something called inline and matplotlib, which works, which used to work with Jupyter. I'm not sure about PyChart, where it will show, sorry, Spider and PyCharm. So it might show it in the same window. I'll check it out, right? So there is an inline option for matplotlib.
Okay.
All right. So yeah. So this is your simple bar chart, right? So if required, right, so you can also specify a palette here, right? So for example, here, I could say palette is equal to, or it's better not. Some good palette, let's say. Let's say Viridis won't look very good, but anyway, let us see. So palette is equal to Viridis, right? And you can say palette is equal to pal. So you can see each bar, right? So is coming in a different color. And those colors are taken from this particular palette. And which palette is that? We have taken Viridis, right? So and if you see Viridis, these are the colors in that, right? So this will take different colors from different palette that you have set. So if you set it as set 2, right? So each bar will take colors from set 2, right? So if you want to give different colors to different bars, you can go ahead and do that, right? Let me ignore warnings. I don't want that. Let's ignore. All right. So this is your simple bar chart, right? So then you can check out all the other plots, right? So the only thing we need to do is we just need to specify the kind, right? So the kind is whichever kind you want. So let us see a swarm plot, for example, right? So swarm plot or a strip plot, right? So you can try those. So for that, we will take the tips data set and we will try out those plots, right? So we'll say cat plot. Just copy this, put it here, right? And then the data comes from the tips data set. So let us say along the x-axis, I will take the day. What is day? Day is Thursday, Friday, Saturday, Sunday, right? And along y, I will take total bill, right? So it is called total bill. Yeah. So day can be 4 values and total bill is the numeric value. So let us try that. And kind, I will say, is strip. Right. So this is what you call a strip plot. So basically all the points, right? So they come, so if you take this particular point, you take this point. So this belongs to a person who had, who went out to have food on Thursday and the total bill he paid was so much. So each point will tell you the corresponding information, right? So this is for somebody who went out on Friday and they spent around so much. So here, if you see, here again, you can specify the palette if you want, right? So each one will come in a different color, right? So we have already assigned palette as set 2. So I can say palette is equal to PAL. So each one of this comes in a different color, right? But here, if you see, there is a lot of overlap, right? So some smudge is happening here. So we are not able to exactly see how many points are there, right? Because one is on top of the other. So you can go for what is called the swarm plot. So swarm is basically this only, strip only. But instead of putting it one on top of the other, it will just spread it out like this, so that we can see exactly how many points are there corresponding to this total bill, right? So all we have to do is change kind to swarm. Instead of strip, you will say swarm. And can you see it is spreading it out, right? And it looks quite pretty also. Especially when you have a lot of data, it will look like a big Christmas tree, right? So this is your swarm plot. So as you can see, they've made it very easy to write the code. Right? So you just need to change the type of the chart and you can easily get a new one. So one more thing that you can do here, right, is you can add more information to this by specifying a color, right? For example, if I take this one, let's take this, right? So here I can say, let this be, I will add it as a new thing. So here I can say hue is equal to, let's say the sex, right? I think sex is the gender, sex, right? So I'll take this as my hue. So what we are saying is for each value inside the sex column, give it a different color. So that means males will be given one color and females will be given another color, right? So that will make it more, okay, let's do that. Sex is not defined. So can you see the orange is for female and green is for male. So now what happens? We have some additional information, right? Let me also give it some alpha. We'll make it a little transparent. So now you can see we get some additional information, right? So earlier we could say this belonged to a person who went out on Friday and he spent so much. But now we also know that this person is a male because of the color, right? So some additional information can be provided with the help of colors by saying hue. You can give other information also. For example, if you want to know who are smokers and non-smokers, you can just say smoker, right? So instead of sex, if you say smoker, then smoker will be given one color and non-smoker will be given another color. So now we know this point belongs to a person who is smoking and this belongs to someone who doesn't smoke, right? So it is up to us. Whatever additional information you need to see on the plot, you can specify it by giving different colors, right?
Ma'am, aspects for what we use it, like height aspects,
This is for the figure size,
height, okay.
right? So I told you height and width, right? So height you have to specify and the width is height into aspect. So this is 3:4.5. Right, so that is what this is. You can comment. Okay, sorry. All right. So instead of saying figure size, this is how you need to specify. Okay, so this is your strip and swarm. There is something called violin plot, right? Which may not be, I don't personally find it very helpful, but let us see. Kind is equal to violin. Right, so what this is it is, so we talked about histogram, right? So when you have a histogram and you smooth it out, you get what is called the probability distribution of this. We'll talk about probability distribution next, right? So in statistics. But if you have a histogram and smooth it out, you will get this probability distribution, right? So what you see here is actually the probability distribution, but it's given like this. Right, so instead of mentioning like this, they have given it like this. So the same thing is repeated on the other side also. And in between, they have a box plot. So it's a combination of this histogram, right? So smoothed histogram and box plot. And the point that you see here, this is the median. Right, so you can just see how the data is distributed, right? So we'll talk about distributions and all later, but these are extreme values, right? So these are called the tails of the distribution. So you can see there are tails towards the higher end. So that means there are people who have spent a lot on food, right? So here on Thursday, you can see how much they have spent is much lesser compared to other days, right? So, so this is what you call a violin plot. Here also, if you want to see the difference between males and females, you can add, I'll bring it down, add it again. So you can say hue is equal to sex. So in that case, you will get one violin for males and one violin for females. right? You can also say split is equal to, sorry, is true. So in this case, what happens, instead of seeing two violins, they are combined into one violin, right? So the green side is the male one and the orange is the female one. So instead of seeing two violins, they are combined into one violin, right? So this is about violin plot. I think that is enough, right? So these are some of the plots that are categorical plots that are commonly used.
And we are able to add data labels here.
What do you want to add?
Data labels.
No,
Like we
what,
added na sometime in a pie chart, we added in a percentage form or in any form.
so see, the purpose is pie chart is different, right?
Yeah.
Pie chart labels are different.
Yes.
And for some reason, we don't have that in Seaborn, but everywhere else, right? So the reason we have a label is to give this legend,
Okay.
right? So the label is specified just because you want to see the legend. But in Seaborn, it comes automatically. You don't have to specify a label, right? So you can see it is automatically giving you that information. So you don't have to separately ask for a legend.
Please show that comment not to see the data, the Sibun data.
Which data?
Sibun, which is available in Sibun already.
The data sets.
Yeah.
All right. So now let us go on to a rel plot, right? So in under rel plot, we have two cases. One is line chart and the other is scatter plot. So for line chart, I will read data from Seaborn, right? So there is something called MPG, that is mileage per gallon. So I can say SNS dot load data set MPG. And what is there in this dot head? So you have details about different vehicles, right? So mainly about mileage per gallon, number of cylinders, weight, acceleration, model year, origin. So from which country it is coming, right? So there are three values inside uh, origin column, right? And so if you want to see what all values, unique values are there in a column, you can just say from MPG, take origin and origin. And you can say dot unique. Right, so you can see there are three unique countries, one USA, Japan, and Europe, right? So we will use this. So you have model year, MPG, then cylinders, horsepower, weight, acceleration. So we will use this information, right? So to create our line chart. So to do that, right? So the thing is, just a moment. Just 1 minute. Sorry. So we will take model year versus MPG, right? So we'll go for a line plot here. So I just need to say SNS dot rel plot. From where is the data coming, right? So data comes from my MPG data set. X is equal to, we'll take model year, model underscore year, and Y is equal to, Y is equal to MPG. So we have mentioned the data, right? So now we have to specify what kind is required. So kind is equal to line. So I want a line chart. So let's leave it here, right? So let's do the basic and then we will add more information, right? So let us try this. I can say plt.show. So you get a line like this, right? So you see when we talked about the different data, different charts, so different types of chart, we mentioned that we will go for line chart only when we have one X has one Y value, right? But in this case, one X has multiple Y values. So that is why you're seeing a shadow there, right? So that is the range of values for this particular, let's say for 72, these are the values that you have for MPG, right? So Seaborn allows you to do this, but it will show you this shadow, right? So if you don't want that shadow, you can just say CI is equal to false. So in that case, that line goes off, right? So now it is very easy to add more information here, right? So I can say, for example, style, right? So style is equal to, I'll say origin. So what that means is for different countries of origin, use a different line style, right? For USA, you use one style. For Japan, maybe dotted line, right? And the other one, right? So Europe. So let's see what happens if I say style is equal to origin. Can you see? Each country of origin has been given a different color. Sorry, different style. Right, so one is dotted. So Europe is dotted, Japan is dash, and USA is a solid line. So here also, if this is not very, the color is not very, very good, right? So what we'll do, we'll say palette is equal to viridis. So that has a little darker shades. So this is still coming the least one only. But what we will do, we can also say hue is equal to origin. You can give it as a different column, but I'm choosing it as the same column, right? So what that means is, see, I have given style as origin and hue also origin. So what that means is, for each country, give it a different style and give it a different color, right? And the colors should be taken from the Viridis palette, right? So let us see if that works. Now, can you see each country has been given a different color and a different style, right? So, so this is what it means. Whenever you say style is equal to some column or hue is equal to some column, it means for different values inside it, use different styles. Right. So again, here for different values in this column, give a different color. Right. So that is what it means. So, so this is, so you can see it makes it very easy to draw line plots and make it look really nice, right? So this is your line plot. Coming to scatter plot, right? So we will take that housing data. I think it was called price or prices or something, right? So prices dot head, or was it price? Huh. So here we had already loaded this data. So what we'll do, like we did for in Matplotlib, we will take the area versus price, and we'll do a scatter plot. So let me copy this. So this is still a rel plot, and we'll say kind is equal to scatter. Scatter. The CI is not required. This is also not required. Okay, let us look at it. Oh, I have to change. I have to take the data from prices. And along x-axis, I will take square feet living. And along y-axis, I'll take the price. Right. So let's see. So here you get a simple scatter plot. Again, you can set the height and the width. Right. So height, I'll say 4. And aspect, let's make it twice. Right. So I don't want it this big. I'll make this 3. So this is your scatter plot, right? So this is your basic scatter plot. But of course, you can add additional, you can beautify it a little bit if you want. So you could, let's give different colors for one second. Yeah. No, sorry. So this is your scatter plot, right? So just change the kind to scatter and give. So here also, if you want, you can give hue. Let's say number of floors, right? So I'll say hue is equal to floors. And each, so different floors will be given different color, right? So this is 1 bedroom. Sorry, what is 1.5 floors? Maybe some mezzanine floor or something, right? So this is for 2 floors and 3 floors. So as you can see, there are very few houses with 3 floors, mostly 1 floor and 2 floors, right? 1.5 maybe somewhere here, right? So you can specify an alpha and make it a little transparent. Right? But anyway, this is how it is. Right? So, so this is your simple line, scatter plot. Let's also make size. Okay, let's add size like we did last time, right? So we'll say size is equal to square foot living, right? So square feet underscore lot. So you can see the bigger sizes, it's not very different, right? You don't see that much difference. Let us divide it by 100. Do that here, right? Because we are only giving the name of the column, right? So I can't do that. So this is not very helpful. Anything else? Bathrooms, let us try. bathrooms. What does this mean? 4.2 bathrooms, 1.2 bathrooms. Yeah. Anyway, fine. But it's possible to add size and color to it based on some columns, right? So this is your scatter plot. So these are the two plots which come under the rel plot category, that is two numeric columns, right? But for the middle ones, you have to specify the actual this dist plots, right? So here you need to specify these names only: hist plot, KDE plot, right? So we won't go into ECDF and drug plot, but hist plot and KDE plot we'll see, right? Hist plot is your histogram. So I can just say SNS dot hist plot. Data, I'll take prices, and X is price, right? Let us see if what this shows. So you got a histogram, right? So now, if you want, see, I told you if you smooth this out, right? So you will get what is called the probability distribution, right? So to do that, you can mention KDE is equal to true. So in that case, can you see a line like this, right? So this is the, I think, color also I can specify. Color, what color can we take? Purple. Let's try purple. Let it be. So this is, so you can see the smoothed out curve, right? So this is called the probability distribution curve. So you may not want to see it along with your hist plot. So in that case, what you can do, you can go for the KDE plot, which will show you only the smoothed version, right? It will only show you the probability distribution. So here you will say, instead of hist plot, you will call it KDE plot, right? KDE is equal to true. And you see, this is giving you only the, so this is more helpful in understanding what is the kind of distribution you have, right? Again, it's a preference. If you want to see it along with the histogram, you can do that. If you don't want to see this, you can just comment it out, right? So you don't need to see the KDE, then it's fine. You can only look at the histogram, and KDE plot can be drawn separately. So here I think you can also say fill is equal to true. So this area gets colored, right? So area inside this will get colored. So I can say fill is equal to true. So inside it also it gets colored, right? So if you want, you can have it that way, or you can leave it out, right? So this is a histogram and KDE plot. Coming to rug plot, it's not really that helpful. We don't use it so much, but maybe we can take a look. So we can say SNS dot rug plot. Let's say data is equal to prices. And X equal to price, right? Height or something is there. Height, right? So 0.025. So height is equal to 0.075. Let us see. Okay, that is also small. 0.15. So you can see this looks somewhat like a barcode, right? So like the price and all is given. So what it means is in this range, right? So wherever you have darker things, there are a lot of, so if you are looking at the price, right? So there are a lot of houses in this price range. But if you see, there are very few houses in this range, right? So that is all it says. The darker it is, it means there are more data points in that area, right? So usually not used that widely, right? So color, let's see if it takes color. It's not there. Palette. That may not help. Al is equal to SNS dot color palette. Let's take Mapo. Right. Let's see how it looks. It's still taking that. Let's see what it says. Let's try hue order. But I think for that we need to specify. Anyway, this is not that useful, right? So it looks like, so you can adjust the height of it. You can make it 0.30 or 430, let's say. Looks a little bigger, right? So this is what you call a rug plot, right? So these are all the different plots that are there in Seaborn. There are other plots also, right? But this itself is a big topic, right? So if you want to look at all the options of plotting, that would itself take around 2 to 3 months. But there is something called the pair plot, right? So pair plot and matrix plot, so you have something called matrix plots. So matrix plots are plots which are shown as a matrix, right? So it will be shown like a matrix. So, so such presentation are called matrix plots. So there are two here. One is called a pair plot, and the other is called a heat map. So what pair plot will do is it will give you, so let's say you have a data set, right? So you have a data set with the different values of in columns, right? So x1, x2, x3, right? So these are all different columns in your table. I'll have only 3. So let's say this is your data, right? So, and let's say these are all numeric data. So what a pair plot will do is it will create a plot like this. Right, so it will create a plot like this with x1, x2, x1, x2, right? So it will take x1, x2, x3 and x1, x2, x3, right? So the purpose of this plot is to look at the relationship between different points in the data set. So basically what you have here is a scatter plot, right? So multiple scatter plots are given. So here you will have a plot with x2 along x-axis and x1 along y-axis. Here you will see something with x2 along the x-axis and x3 along the y-axis. What will be here? There is no point plotting a point with respect to itself, right? So x1 versus x1 doesn't make sense. So what they have done is, in this area, they have given the histogram of x1. Here you will have the histogram of x2. And here it will show you the histogram of the third feature, right? So along the diagonals, you will see this histograms. But on the left side, you will see here it will be x3 versus x2. Right. So if you see these are just the reverse, right? See, this is x2 versus x1. Here it will be x1 versus x2. So normally you won't look on the other side of the boundary, the diagonal. Only these you need to see, right? So now what happens at one glance, I know what is the relationship between all the three variables. Right, so here it tells me that x2 and x3 doesn't have any relationship, right? Because it looks like this, but x1 and x2 have very strong relationship. Right, so at one glance, so if you have 10 columns, if you do a pair plot, all 10 columns will be displayed, and the relationship between them and the other columns, right? So this is called a pair plot. A heat map is used to represent the value of something. It can be anything, right? So the value, depending upon the value, each cell will be given a different color, right? So let us do this, then we will see. So we'll say SNS dot pair plot. I don't know if we have to separate X and Y, numeric and non-numeric. I have to specify the data, no? What do I give? Prices. It's too big. So maybe we'll take tips, right? So that is smaller. That's why it has taken so long. So we'll take the tips data. So now this is easier, right? So you have total bill, tip, and size. These are the three numeric columns in the tips data set. So as you can see, there is a strong relationship between total bill and tip, right? So you can see roughly if the total bill is increasing, the tip is also increasing, right? Whereas here, there seems to be no connection, right? So there is no connection between how many people went for food, and there is roughly, right? But see, this is roughly the amount when 2 people are going, 3 people are going. We'll talk about categorical data and all later. right? But at a glance, it is showing you the relationship between all the all the numeric data in your data set, right? So I'll say plt.show, otherwise it will show that message. You can also specify hue here, right? So you will have more information. I'll say hue is equal to 6. Yeah. So now can you see? For males, it is blue color and females. So this probability distribution itself has been split into two, right? So for males and for females. So you get additional information here, right? Viridis palette would have been better. Okay. Anyway, you can set whichever palette you want, right? So this is your pair plot. So finally, you have something called a heat map. And to do that, what I'll do, I'll take prices dot CORR, right? So CORR gives you the correlations. So can you see it is giving you a, what do you say, a matrix like structure. So what will happen in a heat map is, see wherever the value is more, right? So it will give more darker shades. You can't say darker, it will give you different shades. So just by looking at it, you will know which is higher value, which is lower value, right? So what we can do, we'll take this, right? So I'll put it into a variable called CORR. And I can create a heat map, right? So SNS.heatmap. I'll pass the CORR. So can you see this light shade, right? So white color or almost creamish color is 1. And negative values are here. 0 is somewhere here, right? So as you can see along the diagonals, you have the maximum value. Or you can say it is, this is 1.2, right? So here you have, did we not print it? So here, if you see along the diagonals, you have 1, right? So 1 is the highest possible value. We'll talk about what it is later, right? But for this, 1 is the highest possible value. So that comes along the diagonal. So that is why we see a light color along this, right? Because 1.2 is represented by this color. So everything else comes from here, right? So you can look at the scale and you can see. So if you have this black color, it means it has a very high negative value. These lighter shades basically mean they have a high positive value, right, for correlation. You can also say, I think this is a little small, but let's see. You can say A0 is equal to true. Right. So I think figure size has to be changed. Let's take height. That is the thing here, right? So some things it will take in setting the height. So this looks bigger, right? So you can format it You can annotate it. So you can see what is the value. So this is positive 0.53. Here you have 1. This is negative 0.68, right? So these darker shades would be negative values. And this lighter shades are high positive values, right? So this is what we call a heat map. So we will discuss these two in detail in statistics, right? But for the moment, it's enough to know that you can plot it, right? So this enough, I think, for our visualization. So we have seen enough examples, right? So let us save this. I'll upload this to your drive. And let's take a small break and come back. Right. So it's 1:20. Let's come back at 1:30. Right, and we'll look at an introduction to Yeah, hi. So, let's, so we are done with our Python part. Okay. So we will start off with statistics. So from an interview perspective, statistics is very important for you, right? So you'll be definitely asked more questions in statistics than Python probably. So we'll get an introduction to statistics, right? Some basic concepts in that. So whenever we talk about a new topic, right, so whether it is Python or R or whatever, we have to see how data is understood, how it looks at data. So when it comes to statistics, right, so it looks at data from two perspectives, right? So one, whether it is numeric, and the other is categorical. So what do we mean by categorical data? Anything that is used to categorize the data set, right? So usually this will be non-numeric data, right? So categorical can be numeric also, rarely, but usually it is non-numeric data, right? So this is used to categorize your data. So examples would be gender, race, religion, right? So city, country. So based on which you can divide the data set. So that is called categorical, right? Numeric, we know, numeric data are numbers. So again, data can be divided as discrete data and continuous data. So when you say discrete data, right, so only certain values are possible. Only certain values are possible. And usually, right, so this is something that can be counted. Right, so anything that can be counted, you would call it discrete. For example, number of students in a class, number of cars manufactured in a factory, right? So or number of children in a house. So in this case, right? So when we are talking about discrete data, usually fractions will not make sense. Fractions don't make sense. Right? So you don't say there are 2.5 students in the class, or I have 3.5 children, right? So fractions don't make sense here. So if you take it on a line, if you plot it on a line, the values you can get can only be certain values. For example, if you're looking at, let's say you're doing a survey, right? So all over India, you're going and you're figuring out how many children are there in each household. So there might be 0 children, 1 child, 2 children, 3, 4, 5, right? So after you complete your, every time, so if a house has 3 children, you will make a mark here. If the house has 2 children, you will make a mark. Third house has 3 children, you will make a mark here, right? So by the time you complete going through all the household, you will still see only these points. You won't see values other than whatever, let's say maximum number of children in a house is 10. So other than these values, right? So you will not see anything else. But continuous on the other hand, right? So is something you could say that is measured. Right? So something that is measured. For example, you can have heights, weights, right? So height, weight. So here it is not possible to say we cannot say only certain values are possible, right? Here, any value is possible is possible within a range. Within a range, right? So let's take the same example. Instead of figuring out the number of children in a household in India, you go all over India and measure the heights of people and make a note of what height they are. So let's say the shortest person is 130 centimeters and the tallest person is 200 centimeters. Is it possible to say how many values are possible between these two? How many values are possible between 130 and 200? How many values? Sorry,
70.
7,
70.
70, why 70? You are assuming that it's possible to have 131, 132, 133. But what if there is a person whose height is 132.5? What if there is a person whose height is 132.12? What if there is a person whose height is 135 point something else? Right? So it's not possible to say that people's heights can be only these values. So by the time you complete going through all the people in India, you will have something like this. Right? So you will have a continuous values. So this is what we mean by continuous data. Any value is possible within a given range. Whereas here only certain values are possible, right? So usually anything that is measured, you would call it as continuous. And here fractions are meaningful. Fractions are meaningful. Okay, so this is how data is looked at from the perspective of statistics, right? Let me open the PPT. You can tell me if these things are categorical or numeric. Time, is it categorical or sorry, is it discrete or continuous?
Continuous.
Continuous.
This is continuous, right? So fractions are meaningful here. Money?
Discrete.
Yes.
Money is also continuous. I can have 4.50 rupees. I can add up a column of money and I can say I have 4.175. Right. So fractions are meaningful. So this is also continuous. Length?
Continuous.
Number of laptops?
Discrete.
Number of cars?
Discrete.
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 Okay, let's say discrete. We don't know what that is. How about number of shirts?
Discrete.
Volume of a cereal box?
Continuous.
Speed of a car?
Continuous.
Continuous.
Population of a town?
Continuous.
Continuous.
Why continuous? You have 10.5 people in a country. This is discrete. Right? Number of people.
Like
That
it
is
is
what-
counted.
Sorry?
We can count it.
You can count it.
Count it. So it is discrete.
So it's discrete. Right. Length of a crocodile?
Continuous.
Number of matches,
Discrete.
temperature,
Continuous.
Continuous.
number of poles,
Discrete.
Discrete.
right? So this is how you can differentiate between discrete and continuous. So why is this important? When we are doing analysis, we will select what kind of analysis we want to do, depending upon whether we are working with the discrete data or continuous data, right? So this is how data is looked at. So now coming to statistics itself, we'll be talking about two types of statistics. We'll be talking about descriptive statistics and inferential statistics. So what is descriptive statistics? We will be describing the data, right? So we'll describe it as such. Describe the data. So what do we mean by describing the data? Let's say you are given details about students in a class, right? So you are given an Excel sheet and you have to explain it to somebody else, right? So there is only you can see it and you need to explain it, right? So you want to say, how is the data? So you'll have student ID, name, gender, age, course, right? So how will you describe this? Probably you will say there are n number of students, right? So let us say 100 students in the class. So there are 70% are males and 30% are females, right? And majority of the people in the class are above this particular age. So this is what we mean by describing. You will say the average age of students in a class is roughly around 25, right? So this is what we mean by describing the data. And to describe it, we need certain measures, right? So here we'll be talking about measures of frequency, measures of central tendency, measures of dispersion, measures of position, right? So there is also measures of shape, which we'll see later. So these are the different measures that we'll be talking about under descriptive, right? So what are the measures used to describe the data as it is? Inferential statistics is used to draw conclusions, right? So here we are not drawing any conclusions. Here we have to draw conclusions, right? So in this case, we'll be talking about something called population and samples, right? So what is a sample? Sample is a subset, right? For example, if I want to see how our students in Excel are doing, so the population would be all students in XLR, right? So all students in XLR is what we mean by population. But then it is not possible for me to do any analysis by asking every student in XLR. So what I'll do, I'll take a sample. I'll ask some 100 students or 50 students. I'll ask some questions and I'll figure out how they are doing, right? So now based on the sample, I want to see, let's say I see that 70% of people have got placed, for example. So what I'll do, based on this, I will draw some conclusion about the entire population. Okay, that is called inferential statistics. Trying to decide something about the entire population by doing analysis on samples. And to do that, there are certain techniques, right? So specifically, we'll be talking about hypothesis testing. Very, very important from interview perspective, right? So here they will give you a scenario. They'll give you a scenario and they will ask you, first of all, you should be able to explain what is hypothesis testing. And they'll give you a scenario and they'll ask you what kind of test will you perform on this. right? So that is very, very commonly asked. So, so hypothesis testing is what will be one of the things that you will be doing under inferential statistics. So here we are drawing some conclusions. We are not just describing it. Based on the sample, we are coming up with some predictions or conclusions about the entire population, right? So this is what we will be doing. So I think we may not have time to start it off today. Tomorrow we will talk about, we'll start with populations and samples. And then we'll talk about the descriptive part. And then we'll talk about the inferential testing and all, right? So how to do the hypothesis testing, right? So we have already exceeded by 2 days because we added visualization, but that's okay, right? But fine, so let's stop for today, right? So tomorrow we will continue with the different types of statistics. Think nothing today, right? So nothing to share. I think the code file I've already uploaded, the visualization I've already uploaded. This tomorrow I will upload, right? All right, then let's stop for today. Sorry, why are we stopping now? It is still 2 o'clock, no? Yeah, 10 minutes. Okay, let us stop. See you all tomorrow. Have a nice day.
Thank you, ma'am.
Bye then.